Back. Today we continue our course in system design fundamentals. Today we will talk about the matrix. So let's say that we have the system, and let's just make a quick quick review of what the system is and what every component is doing, and what are the benefits that we are getting by adding matrix to the system. So we have the client. The client gets the IP address of the client wants to connect basically with the web server, so it will try to connect with the load balancer, and in order for the client to connect with the load balancer, the client needs the IP address of the load balancer. So the way that the client could reach or could get the IP address in the load balancer is by DNS, domain name system, which the domain name system transform the human-friendly reading domain names like youtube.com, google.com into IP address. So the user will get the IP address from the DNS, and when the user obtains the IP address, it will try to connect to the load balancer. Also, the user is connected to the CDN, Content Delivery Network, which was responsible for managing to serve the static data like images, CSS, and HTML files. And also the user will try right now. The user have these two main components. The user right now have the IP address. It will try to connect to the load balancer. The load balancer purpose is that because we have, as you can see, we have more than one server to serve the traffic, because we have distributed system. We need the load balancer because the load balancer purpose is to distribute all the incoming requests that are coming from the client to the web server. So we make sure that no web server is overloaded with the requests, and there is no web server is not touched at all. When the load balancer try to distribute all the incoming requests across the web servers try to make a read or write request to the database. Of course, the system it could be much complicated than that. Could we have a cache system to make sure that we can find the frequently to save it in it frequently accessed data to improve the overall performance and the latency to the system. We could also have message queues for the asynchronous tasks. But let's just keep it simple because we only want to talk about the matrix right now. And right now we have database it serve the read and write, and we have the logging here. And the logging in distributed system is a crucial aspect of maintaining system health, diagnosing issues and monitoring performance, and ensuring overall reliability and detect the errors. Right now we want to add a new component to the game, which will be the matrix. So what are the matrix and why we need them? So the matrix in distributed system are quantitative measurements that provide insights into systems behavior and also systems performance and systems health. These metrics are collected and analyzed to monitor, troubleshoot, optimize, and ensure the reliability of distributed systems. And let's talk about why we need them, because there is a lot of benefits that are coming from it. So the first thing that that we need, why we need the monitoring. Let make this quite smaller. The first thing is that we need the monitoring. Let me copy that so it will be easier for us to look at it. Its first thing is the performance monitoring. The metrics help you track the performance of various system components such as servers, databases, and microservices. Performance metrics can include response time, throughput, resource utilization like CPU, memory disk, and network latency. Monitoring performance allow you to identify any bottleneck that you have and optimize resource allocation and ensure the system meets performance requirement. So it seems like it's doing a lot. The second thing is that helping in the fault tolerance. And in terms of that, in the fault tolerance is that the matrix can be used to detect abnormal behavior and potential faults or errors within the distributed system. Sudden spikes in error rates or a sharp drop in throughput or unusual high resource consumption can all be indicators of issues that require attention. Also, we can use capacity planning. Like, let's just put this one as there's more things that also we can do, like just maybe 12 things come to my mind right now, and I'll put all the reasons in the description so you can read them and go through them. So the capacity planning, also understanding resource utilization metrics is crucial for capacity planning. By analyze these metrics, you can predict when the system might run out of resources, like the CPU, memory, and productivity, allocate additional resources, or scale the system to accommodate increased load. And this also, that means that it's a great tool in the scalability assessment, and it's a great tool for also it's a great tool to in load balancing. Yeah, it's been used in the load balancing. So in conclusion, basically the metrics can inform the load balancing decisions. Load balancers often use metrics like server response times or the number of active connections to distribute traffic intelligently among backend servers. And this only 4 reasons. I guess in the description you could find more reasons, and I highly recommend you to read all of them and memorize all of them. So that's it for today's video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future problems.